Hello, today we are going to discuss about two additional features of SQL, that is assertions and triggers. And in the last classes we were discussing about how different constraints can be specified in SQL, like how it is referential integrity or unique key constraints, etc. And for all these constraints, we were able to specify them using the built-in relational model constraints itself. But there are certain other constraints that are outside the scope of this built-in relational model constraints. Okay. That is today's topic. It is specific constraints as assertions and actions as triggers. So here we have assertions and triggers. Assertions means we can specify additional types of constraints that are outside the scope of the built-in relational model constraints. We have seen so many constraints earlier that were discussed using the built-in relational model constraints. But here we are focusing on some additional type of constraints, and that can be specified using the assertion. Then we have the triggers, and triggers are used to specify some automatic actions that are to be performed when the database system will perform some actions, okay, or that perform certain events and some specific conditions occur. Okay. So these are used to specify automatic actions that the database system will perform when certain events and conditions occur. Okay. That is, there should be some provision to monitor the database activities, and the corresponding actions should be taken when particular events occur. For this, we can use this triggers, and this functionality generally called as active databases. Okay, so let's see what is meant by this create assertion. So we have seen that these assertions are used to specify certain constraints that are outside the scope of this built-in relational model constraints. So suppose we want to specify some constraints which cannot be specified using the relational model constraints. For example, specify a query that selects any tuples that violate the desired conditions. Okay, so we can use this create assertion using for specifying a query that selects any tuples that violate the desired condition. So here we are using the constraint. The constraint name is salary constraint. Okay. And that is followed by, we have a keyword check, and that's used to specify the condition. And this condition is similar to the where clause of an SQL query. For example, suppose we want to specify the constraint that the salary of an employee must not be greater than the salary of the manager of the department that the employee works for in SQL. Okay. So we can write that like this. So we are checking whether the salary of an employee is greater than the salary of the manager of the department that the employee works. So this, actually we should ensure that the salary should not be greater than salary of the manager. So create assertion, here giving the assertion as constraint name as a salary constraint, and that is followed by a check, and which is followed by a condition, and that condition be given in parentheses. Okay, and this must hold true on every database state for the insertion to be satisfied. Okay, for the assertion to be satisfied, the constraint name can be used to later disable the constraint or to modify or drop it. And the DBMS is responsible for ensuring that the condition is not violated. So here, whenever some tuples in the database cause the condition of an assertion statement to evaluate to false, the constraint is violated. Okay, so we can say in that case the constraint is violated. The constraint is satisfied by a database state if no combination of tuples in the database state violates the constraint. If that is the case, then we can say the constraint or the database satisfies this constraint. Okay. So here we are select star, so which means we'll be taking all the tuples from this table and from employee and department table, employee and employee, we have given different aliases, and where we are checking E dot salary is greater than M dot salary, and these are joined using D number and SSN. Okay, so E dot D number equal to D dot D number, and D dot manager SSN equal to M dot SSN. So this is how we join them, and we take all the tuples from this database which select which satisfies E dot salary greater than M dot salary. Okay, and if what it says is that not excess. So if this query returns empty, or if it returns null, then this database satisfies this assertion. Okay, that's what it says. Okay, so if this returns empty, then the assertion is satisfied. So the basic technique for writing such assertion is to specify a query that selects any tuple that violates the desired condition. So we are taking any tuple that violates the desired condition, and then what we can do is, by including this query inside this non-excess clause, the assertion specify that the result of this query must be empty, so that the condition will always be true. So that is the use of not excess. So we can say the assertion is violated if the result of the query is not empty. Okay, so here if this query is not empty, the assertion is violated. And here we can note that the sets, here we have a set clause, and constraint condition can be used to specify constraints on individual attributes and domains and on individual tuples. So here there is a major difference between create assertion and the individual domain constraints and tuple constraints is that the check clauses on individual attributes, domains and tuples are checked in SQL only when the tuples are inserted or updated in a specific table. So that is, we say a constraint checking can be implemented more efficiently by the DBMS in these cases. So the schema designer should use check on attributes, domains and tuples only when he is sure that the constraint can only be violated by inserting or updating of tuples. Okay, so that is this. We can say this is used only in cases where it is not possible to use check on attribute and domains. And another important statement in SQL is a create trigger. And in many cases, it is convenient to specify the type of action to be taken when certain events occur. Okay. And when some conditions are satisfied. So, that is, for example, we say it may be possible to specify a condition that, if violated, causes some user to be informed of the violation. So, for example, if a manager may want to be informed if an employee's travel expenses exceed a certain limit by receiving a message whenever this occurs. Okay. So, the action that DMS must take in this case is to send an appropriate message to that user. The condition is thus used to monitor the database. Okay, so here the condition is thus monitor the database. And the trigger is usually used to implement such actions in SQL. Okay. So, whenever some condition was implicitly, the condition is used to monitor the DBMS, then the actions may be used to send some messages or maybe to execute some stored procedures or to trigger some actions. Okay. So, the trigger is used to implement such actions in SQL. That's what we said. Here, when we consider these triggers, this will have any triggering rule has mainly three components. So, the first one is events. These are usually database update operations that are explicitly applied to the database. Okay. So, that is known as events. These are update operations that are explicitly applied to the database. So, then after this we can specify a condition. We have a condition, and this condition means that determines whether the rule action can be executed. Thus, once a triggering event has occurred, an option condition may be evaluated, and if no condition is specified, the action will be executed once the event occurs. If a condition is specified, then it is first evaluated, and only if it evaluates to true will the rule action be executed. Okay. So, the condition is specified in the when clause of this trigger. And the third part is we have an action to be taken. The action is usually a sequence of SQL statements. It may be like an external process that will be automatically executed. Okay. So, let us see an example for this. So, here again consider we have suppose we want to check whenever an employee's salary is bigger than the salary of his or her direct supervisor in the company database. Okay. Employee's salary is greater than the salary of his direct supervisor in the company. Okay. So, several events can trigger this rule. So, that is we need to monitor this DBMS, and if some events occur, then that will trigger this rule. Okay. So, we need to perform some actions. So, what are these several events that can trigger this rule? So, for example, suppose we are inserting a new employee record, okay, or changing an employee's salary, or changing an employee's supervisor. In all these cases, there are chances that the employee's salary is greater than the salary of his direct supervisor. So, we need to check all this. Okay. So, we can write this as trigger. So, here for example, we can use salary violation as a trigger. So, create trigger, and the trigger name is the salary violation. Okay. So, here we have event. we can specify these events. And we know that there are different events that can trigger this one, that is salary violation. Maybe inserting an employee or update salary of an employee or supervisor of an employee, etc. So there, these events, the person who writes the trigger must make sure that all possible events are accounted for. So when we write the trigger, so we should make sure that all possible events are accounted for. So for example, in some cases, it may be necessary to write more than one trigger to cover all possible cases. And these events are specified after this word before. Okay, so this event must be specified as a keyword after this before, or we can use keyword after. Okay, and we are using this before, keyword before. It means that the trigger should be executed before the triggering operation is executed. Okay, so here the trigger should be executed before the triggering operation is executed. So what are the triggering operations here? For example, insert or update this salary, etc. So these are the triggering operations. And trigger is used to check the condition, whether that violates this condition or not. Okay. And action will be maybe some stored procedures. Okay. So here before is the condition, and before triggering operation insert or update of salary supervisor underscore SSN on employee. Suppose we are trying to insert some employee in this employee database, or maybe we are updating salary of some employees or supervisor of an employee. Okay, so in that cases we need to execute. Just before that we need to execute this trigger. Okay. And what is that trigger? For each row, we need to check for each row when new dot salary is greater than. So what we need to check? The employee's salary should not be greater than the supervisor's or manager's salary. So new salary is greater than. We need to select salary from the employee, and the condition is SSN is equal to new dot supervisor underscore SSN. Okay. So that is the condition, SSN equal to new dot supervisor underscore SSN. There we need to select, that is we need to take a supervisor's salary, and we need to check whether new dot salary is greater than the supervisor's salary. And if that is the case, then we can call a stored procedure. So here inform underscore supervisor is a stored procedure that will be executed when this particular condition is satisfied. So that is to inform the supervisor, that is invoking a stored procedure, and that is with arguments new dot supervisor underscore SSN comma new dot SSN. So we are applying this supervisor's SSN and new SSN to this stored procedure. Okay, and that will actually inform the supervisor about this. Okay. So this is how we can create triggers in our SQL. So create trigger, and we need to give the trigger name, that is salary violation, and we need to specify when to perform this triggering actions. Okay, so here before insert or update of salary and supervisor underscore SSN on this employee action. And for each row, when salary is greater than supervisor salary, then it will inform the supervisor. Okay, these are two additional features of the SQL. Okay, and that's all for today. Thank you.